Okay, so reading the practice internal 2, first thing we need to do is figure out what the dimensions of our base could be. So the base can't exceed, so be greater than 18 centimeters squared. So this could be 9 centimeters by 2 centimeters, 6 centimeters by 3 centimeters. Alright, if we look at these two different dimensions, we want to be able to put four different squares, so 4 different pieces of gum into it. So if we have 3 centimeters by 6 centimeters, it's going to be a bit tricky, because if we have a square that's 3 centimeters by 6 centimeters, the biggest, we can only get 2 there. So the squares then aren't really going to fit in. So what we could actually do is we could divide 6 by 4 and have 4 little squares in there. Otherwise, if we use this one here, we could have each square being 2 centimeters by 2 centimeters, another one being 2 centimeters by 2 centimeters, and then what you can see we've got here is we've got 4 squares. So we've got our 4 squares for our chewing gum, and then we got this 1 square left over. So this box of 9 centimeters by 2 centimeters is going to be our best bet for the package. And then each piece of chewing gum is going to be 2 centimeters by 2 centimeters long here. So each piece of chewing gum is going to be 2 centimeters by 2 centimeters. So that's what we're going to work on. So we're going to choose base of 9 centimeters by 2 centimeters. This fits 4 chewing pieces of chewing gum with the base of 2 centimeters by 2 centimeters. Right. So each piece of chewing gum is going to be 2 centimeters by 2 centimeters. Okay, now volume. So the volume of each piece of gum is going to be 3 milliliters, which is equal to 3 centimeters cubed. So the first thing we did is we did the base dimensions, and then we're doing the volume conversion. Alright, now what we want to look at is we want to look at how each of these 3 shapes can have a volume of 3 milliliters. So let's start with the pyramid. So pyramid volume. Volume. Right. So the formula is the third times the height of the pyramid times the width of the pyramid times the length of the pyramid for a square pyramid. So volume of square pyramid is equal to that. So that is also the same as height times width times length. Now the base of the pyramid, we're already given it. So the base of the pyramid is 2 centimeters by 2 centimeters. So the width is equal to 2, length is equal to 2. And then we also know that the volume is going to be equal to 3. So what we're saying then is that 3, because 3 is the volume that we want each piece of gum to be. So the volume of each piece of gum is 3, so that's the volume. And then the formula is a third times the height times the width, which is 2, times the length, which is 2 as well. So what we've got is 3 is equal to 2 times 2 times a third. So we've got 4 over 3 times the height, and then what we can do is we can divide this side by 4 over 3, and then we're going to get our height. Or another way of doing it is if we use the pyramid volume calculator. So we can change our formula to the volume as the length times the width times the height divided by 3. We know what the width, the length, and the volume are, so we can now put it into this formula. So the volume is 3, the length is 2, and the height is, not sure, the width is 2. So now what we can do is we can take this 3 over to the other side using algebra. So we can multiply the 3 over. So if we multiply each side by 3, we've got 9. And then we've got 2 times 2, which is 4, times h. Now to get that 4 across, we can go 9 divided by 4. We go to the opposite. So 9 divided by 4 equals h. And then on the calculator, if we go 9 divided by 4, we get 2.25. So h is equal to 2.25. So the height of the square pyramid is 2.25 centimeters. Right, now you could also use the pyramid volume calculator, and we could just put in our heights to check and guess them. So we could use the base length of 2, the width is 2, and then we could try some heights. So we could start with 1, got to be bigger than 1 because we want it to be 3, try height of 2, got to be bigger than 2, try height of 3, okay, so the volume's too big now, so it's between 2 and 3, so let's try 2.5, 2.5 too big, 2.4 too big, 2.3 too big, 2.2, we want to get a bit bigger, 2.21, 2.22, 2.23, 2.24, 2.25. So another way of getting the height is by using check and guess through this calculator. Alright. So the height of the square pyramid is 2.25 centimeters. Right, the next thing we can do is we can do the cone volume. Alright, now the formula for the cone is, so the formula for the cone is pi r squared. So cone volume is equal to pi times r squared, and then times h divided by 3. H divided by 3. Alright, now if we have a square of 2 centimeters by 2 centimeters, how are we going to fit a cone base into that? So if we're going to fit a circle, if we're going to fit a circle into a cone base, then the circle is going to have a diameter of 2 centimeters. So if we've got a square of 2 centimeters by 2 centimeters, so this is the base of one piece of chewing gum, if we're going to make a cone fit into that, how can we do that? So we've got a square that's 2 centimeters by 2 centimeters. I then want to put a circle in the middle. So putting a circle in the middle, I'm just going to find my midpoint by using 2 lines to cross over. Okay, so if I put my midpoint there, my radius is going to be 1 centimeter, which means that my diameter is going to be 2 centimeters. So that is going to be the radius of my circle. So my radius is 1 centimeter and my diameter is 2 centimeters. So this length across here, 2 centimeters. The length or the radius is only 1 centimeter. So the diameter of the circle to fit in 2 by 2 square is 2 centimeters. This means the radius is 1 centimeter. So R is equal to 1. And then the volume, we said before, the cone volume, we want it to be equal to 3 centimeters cubed. Alright, now what we can do here is we can put in these calculations. So 3 is equal to pi r squared, our r is just 1, times h over 3. So then that means 3 is equal to pi times 1, because 1 squared is just 1, times h divided by 3. Alright, now to get the 3 across the other side, we do the opposite. So it's being divided there, so we can times both sides by 3. So we've got 3 times 3 equals to pi times 1 times h. And we know that 3 times 3 is 9. We also know that pi times 1 is just pi. So we can just get rid of that one. Alright, now to get that pi across the other side, we divide, we do the opposite of what's happening. So 9 divided by pi is equal to h. And then if we do 9 divided by pi in a calculator, we get 2.86 centimeters. So we get the height is equal to 2.86 centimeters. Alright, now another way of doing this is by using the cone volume calculator. And if I was to do that, we know that the radius is going to be 1. So we can start putting in values of the height to see where we get 3. Okay, so it's between 2 and 3, so we'll try 2.5, 2.5, 2.6, 2.7, 2.8, 2.9, that's too much, 2.81, 2.82, 2.83, 2.84, 2.85, 2.86, so it's about 2.86. And that is what we got here. So you can use check and guess to get the height. Alright, so we've got that just changing these heights. Alright, so we've got that the height of the cone is 2.86 centimeters. So that's to 2dp as well. To give a volume of 3 milliliters. I'll say that back up here as well. So height of the square pyramid is 2.25 centimeters to give a volume of 3 milliliters. Alright, next thing we're going to do the hemisphere volume. Alright, now the volume of a hemisphere is half that of a sphere. So the volume of a sphere is equal to 4 over 3, and then pi times r to the power of 3. Okay, so that is the volume of a sphere. So the volume of a hemisphere is all of that divided by 2. So you can do all of that divided by 2, which is the same as 2 over 3 times pi times r cubed. So that's the volume of a hemisphere. Okay, now the volume of a hemisphere, we know it's going to be 3, because that's what we want the volume of the chewing gum to be. So 3 is equal to 2 over 3 times pi times r cubed. Alright, now for the circle or the sphere, the base of the hemisphere to fit inside our 2x2 box, just like the cone, the radius has to be 1 centimeter. So if we have a radius of 1 centimeter, then we've got the volume of a hemisphere is equal to 2 over 3 times pi times 1 cubed, and 1 cubed is just 1 times 1 times 1, so it's just times 1. So the volume of a hemisphere is equal, so the volume of hemisphere is equal to 2 over 3 times pi, which because the times 1 doesn't really matter, and then so 2 over 3 times pi. So what that volume is 2.09 centimeters cubed, which is equal to 2.909 milliliters. Now that volume is not 3 milliliters, which we're after. So that means that the base of the hemisphere, the radius of the hemisphere, has to be bigger than 1 centimeter for it to work. So the hemisphere is not going to work because the base or the radius needs to be greater than 1 centimeter to give a volume of 3 milliliters. Now, if we wanted to find that out, what the radius actually was, we could go back here and then we could work this out. So to get the 2 over 3 over the other side, we divide 3 by 2 over 3. So 3 divided by 2 over 3 is 4.5. So we've got 4.5 is equal to pi, 4 over 3 is equal to pi times r cubed. And then to get the pi over, we go 12.5 divided by pi, which gives us 1.43. So 1.43 is equal to r cubed. So what we need to do now, so we've got 1.43 is equal to r cubed. What we need to do is we need to take the third root to get rid of the 3. So we go to the power of 1 divided by 3 equals 1.127 or 1.13. So r is equal to 1.13. So a radius of 1.13 centimeters is needed for volume to be 3 milliliters. But this won't fit in the space or in the for the base dimension. And then if we look at the volume of a sphere calculator, if we put in a radius of 1, we can see the volume is 4.19. Remember, that's the whole sphere, so we divide it by 2. And then if the volume was 1.13, the volume is 6.04. So if we divided that by 2, we've got our volume of 3. So the radius needs to be 1.13, about 1.13 centimeters for it to work, but that's too much because 1.13, a radius of 1.13, if we're going to use it in the box, is not going to fit in. So if we look at the box here, if I had my radius of 1.13, the radius is going to be too big to fit in the box, so it's not going to work. Okay, so the hemisphere is not going to work. Okay, so now we need to choosing the best shape to fit in the packaging. So choosing the hemisphere. So hemisphere. The hemisphere is not going to fit as described above. The hemisphere is not going to work. That's out. The cone. Let's have a look at the cone. The cone. What are the dimensions of the cone? So, cone has height of 2.86 centimeters and radius of 2 centimeters. 2 centimeters. Okay, so if it's 2.86 centimeters and a radius of 2 centimeters, let's have a look at how or what the total volume is. we can look at that through SketchUp. So we're going to look at if we had just going to try and move this around. Okay, so what I'm going to do is I'm going to try and show you what happens if we had the height of 2.86. It's a height of 2.86 centimeters. So we have a cone that has a height of 2.86 centimeters. To get rid of these dimensions for now. Okay, so cone is 2.86 centimeters high, has a radius of 2. I'm just going to show you what the cone looks like. Oh, not liking it. I'm deleting that. Also not liking it. Okay, so if we have a cone, it's going to look something like that. So that means to fit that in the box, we're going to get a triangular prism that has a height of 2.86 centimeters. So I'll show you what I mean. So if we have a height of 2.86 centimeters, so if we had 5 of these cones, sorry, 4 of the cones, we've got a bit of wasted space at the end. If we've got 4 of these cones and we've got a height of 2.86 centimeters, you can see if we extended that all the way around, so if that was the whole box, they would fit into a triangular prism. So what I'm trying to say here is the total packaging of the triangular prism would have a volume of would be, so volume of triangular is equal to half times length, so half times length times width times height, and so in this case volume would be equal to half times the length, which was 9, the width, which was 2, so this is of the total box, and the height, which is 2.86. And then if we work this out, so if we work this out, we get 0.5 times 9 times 2 times 8.6, so we get a volume of 25.74. Total volume is equal to 25.74 milliliters. So, and then total volume of packaging, and then so there's volume, and the volume of the gum is equal to, so there's 4 pieces of gum, each at 3 milliliters, so the volume of the gum is equal to 12 milliliters. So the leftover space, or the waste over space, is equal to 25.74 minus 12, and that is equal to 13.74. So there is 13.74 mil of wasted space. Alright, now let's look at the pyramid. So the pyramid. So what does the height of the pyramid? Height of the pyramid was 2.25. The pyramid has height of 2.25 centimeters, width of 2 centimeters, and length of 2 centimeters. Alright, now total packaging for the pyramid would be B is equal to a half times, so it's still going to be in the package that's 9 centimeters by 2 centimeters, but now the height of this packaging is going to be 2.25 centimeters instead, because rather than being our cones here, we have instead a pyramid that has a height of was it 2.25 centimeters? Alright, so the height of the pyramid is 2.25 centimeters. So the pyramid's going to look like that. And now the height of the box saying is going to be a what's it called, sphere that looks like that. So if I spin it around, and finish off making that pyramid. So if I spin it around, and if I extend out the pyramid, we can see the volume of the pyramid is going to be a lot less than the volume of the cone, which is here, because the volume of the cone has to be higher, so there's going to be more wasted space. So let's see what happens here. So the volume is half times 9 times 2 times 0.5. So this is going to be less. So rather than 2.86, it's going to be 2.25. And so we've got total volume is 20.25. So the total volume of packaging for the pyramid gum, the pyramid shaped gum, is 20.25 milliliters. Left of space, I put it there, left over space. So the left over space is equal to 20.25 minus 12, which is equal to 8.25. So there is 8.25 milliliters of wasted space. This is less wasted space than the cone, so the square-based pyramid is the best option to reduce the total materials used. So what we've done is we've explained that the hemisphere is not going to fit in. The cone and the pyramid can both fit in, but the pyramid is going to be the best choice because the height of the pyramid is less, so the total packaging volume is going to be less for the pyramid. And that is the assessment finished.